All right, in section 3.5, we're talking about transformation of functions. Now, before we get into the actual transformations, we need to look at the basic functions. So here we have a constant function, which is really just a horizontal line. Here we have what we call an identity function, but it's really just y equals x. That's just a straight line. What we need to get from each one of these functions that I'm about to show you is the basic shape of them, because we're going to be, as the description says, we're going to be transforming these, so moving them around. Now this is what you call an absolute function. To me, it looks just like a v, okay? Here you've got a quadratic function. It looks like a u. Here's a cubic function. I know how it almost, it goes down, it curves a little, and it goes up, like that. Here we have a reciprocal function, which is 1 over, and by the way, we do need to know the, like with f of x is equal to c. C is just going to be some number, so it's say, in this case, it'd be 2. So this would be f of x is equal to 2. So we're going to need to know the formula and the graph of these. Here we've got f of x is equal to x, and it's just a straight line. Here we've got f of x is equal to the absolute value of x, and it's got a, looks like a v shape. Here we got f of x is equal to x squared, and it looks like a u. Here we have f of x equals x cubed, and it has that shape right there. F of x, 1 over x. Notice how it doesn't go over the y-axis, because if we inserted 0 into this function right here, we would get 1 over 0, which would make the entire fraction undefined. So we have an asymptote at 0. Here we have 1 over x squared. We called it a reciprocal squared function. And this one is not on the negative portion of y, but it is on the negative and positive portion of x. Okay, here we have a square root function. It starts at 0, and then it goes towards the positive x direction. Here we have a cube root function, and it almost looks like x cubed, except for the direction is a little bit different. Okay, so those are our basic toolkit functions, and we need to know the formula as well as the shape, because we're going to be transforming them. The first transformation we're going to talk about is called vertical shifts. So if you have some basic function, and what you do is you add a number to the very end of that function. So say your function is f of x. Then the new function, g of x, would be the function that you had, f of x, plus k, where k is just some number. That's going to be a vertical shift of the function f of x. So that means that all your y values are going to be changed by k units, whatever k is. If k is a positive number, the graph will go up. If k is a negative number, the graph will go down. So like I have here, f of x is this function right here. Okay, and now if I add 1 to it, notice how the x values don't change, but the y values do. All the y values have gone up by 1. Now if we had f of x minus 1, it would be something like this. It would go down 1 unit, okay? So vertical shifts affect the y values only. So let's look at this one. Let f of x be the absolute value of x. If g of x is the graph of f of x shifted up 8 units, then write a formula for g of x. Okay, so we're not graphing here. All we're doing is we're just writing a formula for it. Okay, so if it is shifted up 8 units. So shifted up, that's a vertical shift. That means that's only going to affect the y values. So, whoops. This is now g of x. It would be the absolute value of x plus 8. Okay? And that's it. That is your formula. So this function, the black function right here, that is the absolute value of just x. Now this blue function, that is the absolute value of x plus 8. Notice how it started at 0. That's just the original absolute value of x. But then once we added the 8 to the end, it shifted all the y values up 8 units. Now let's look at this. Let f of x equal 1 over x squared. If g of x is a graph of f of x shifted down 1 unit, then write a formula for g of x. Okay, so g of x is equal to 1 over x squared minus 1. Since we shifted down as a vertical shift, 1 unit, so minus 1. So there's our formula for that. Again, here the black function is our original function, so that's 1 over x squared. The blue function is 1 over x squared minus 1. Notice how all the y values have shifted down 1 unit compared to your original 1 over x squared graph. Look at a table. So here's a table for f of x shown below, and then here's a table for g of x shown below. And this should be g of x. So based on the tables, what kind of transformation did f of x go through? Well, first of all, I'm going to look at the x values, compare them. So these x values to these x values. So the first one's 4, so is this one. -2, well, so is this one. 1, and so is this one. Okay, so there's nothing that's affecting the x values. Then I'm going to compare the y values. Okay, this one's 5, this one's 7. Okay, that's a difference of 2 on this part. 2, 4, difference of 2. 0, 2, a difference of 2. Okay, so only the y values were affected. So that means that we have a vertical shift. And because they went up 2, we shifted up. So that means that we have g of x is equal to f of x plus 2. And that's it. Here we're given a graph of the transformation of y equals absolute value of x. And we didn't even need this part right here because it's a V shape. So we should already know that it's the absolute value of x. So what we need to do is write a equation for this transformation. Now we know the original one would start here at 0 and do something like this. But this one has been shifted up 1, 2 units. So that means that g of x is equal to the absolute value of x plus 2. And that's it. Okay, here we're looking at x squared, which we would already know that because it's a U shape. So we know it should be x squared. Now the original one would start at 0. Do something like that. But this one has been shifted down 1, 2, 3, 4 units. So that means that g of x is equal to x squared minus 4. And that'd be our answer. Okay, so that's vertical shift. Let's move on to horizontal shift. Now, given a function f, a new function g of x is equal to f of x minus h, where h is just some number. That's going to be a horizontal shift. Now, if h is a positive number, the graph will go right. If h is a negative number, the graph will go left. Okay, now the horizontal shifts can be a little bit confusing. Now, I don't look at what h is. I just go ahead and look at what sign they go ahead and give me. Okay, because if h was a negative number, then what we would have is x minus a negative h. And that would really just give me x plus h. Okay, so they said if h is a negative number, you should go left. So what I do is, if this is an already positive sign right there, you go left. Now, if h is a positive number, so x minus a positive h, then what that's going to be, I'll write over here, x minus h. Okay, so since we've got a negative number, and we have a positive number for h, we should go right. So if the number or the sign is negative, then I'm just going to automatically go towards the right. That's how I remember it. That's I think the easiest way to remember it. Okay, so notice this h value is right by the x minus h. So horizontal shifts are only going to affect your x values. Okay, so let's look at this graph I have here. So we got f of x plus 1 and f of x. So f of x is this function right here. All right, now notice if I add 1 to the inside of the parentheses near the x value, notice which way it went. It went this direction, which is left. Notice I have a positive sign here, so we'll go to the left. Now notice the y values didn't change. Your y values are still all the same, but what changed is all your x values. Okay, so let's look at this one. Let f of x equal the square root of x if g of x is the graph of f of x shifted left 5 units, then write a formula for g of x. Okay, so we have to be careful with horizontal shift, since the h value has got to be closest to the x value within the function. You can't just say, okay, it's just this right here or this right here, something like that. It has to be within the function. So this is going to be the square root of x and then something with 5. Now since we're going to the left, this is going to be a positive. And that is going to be your formula for horizontal shift going to the left 5 units for the square root of x. The original function is this black function here. Notice how it's starting at 0 and then going towards the positive x values. Now notice the blue function here, that's the square root of x plus 5. Now notice it has scooted to the left 5 units. So it's starting at -5 and then going towards the positive x values. Okay, let f of x be x squared. If g of x is the graph of f of x shifted right 2 units, then write a formula for g of x. Okay, so g of x. Now remember, since we're shifting right or left, that number is going to be within the function. This function is x squared, so this whole thing will be squared. Now I have x something and 2 because I'm going 2 units. Because I'm going to the right, this is going to be a negative. And that's your formula right there. Notice that the black function is the original function, so that's just x squared. Notice how it starts at 0 and then it goes up. Now the blue function is x minus 2, that whole thing squared. Notice how it shifted to the right 2 units. So it's starting at 2 and then it's going up. Look at a table. We have a table for f of x, we have a table for g of x, and again this should be g of x right here. Now I'm going to compare my x values and my y values and see if anything's different. So the x values for this one compared to this one. Okay, this one's 4, this one's 5, looks like an increase of 1. This is -2, -1. If I did -2 plus 1, that would give me -1. So that's an increase of 1. 1 and 2, again, that's an increase of 1 for my x values. Then let me look at my y values, see if anything's different there. Okay, I got a 5, I got a 5, I got a 2, I got a 2, I got a 0, I got a 0. So nothing changed for the y values, just for the x values. Okay, so what we'd